Hi, and welcome back to our AP Chemistry Flipped Classroom. And today we are talking about solids, liquids, and gases. So we've covered the different intermolecular forces that cause things to be in a particular state of matter at a particular temperature. We've talked about the structure of solids, and now we're just going to kind of review the differences between those three states of matter. So jumping in, we're going to talk about the differences between those three states and what changes in spacing and what changes in movement of the molecules. So a big focus in this unit is those particulate diagrams, understanding, being able to draw what's happening at the microscopic level. So we use particulate diagrams to show the different properties. And so when we look at this particulate diagram, we can see that in our solid, our particles are close together. They're probably in a fairly uniform repeating structure. We would call that crystalline if that's the case. In a liquid, we see that we have more movement and more space and a lot less order. And then when we move to a gas, we can see that we have lots and lots of movement, that our molecules are very, very far apart, very spread apart, and that they're moving really quickly. So when we talk about a solid, our particles in a solid don't have a lot of kinetic energy. They can't move freely, they can only vibrate. So there's not a lot of space between the particles. Those intermolecular forces or those intramolecular forces are holding those particles strongly in place. They have a fixed volume and a fixed shape. Solids, generally speaking, cannot be compressed because the particles are so close together. Our particles can be arranged in either a crystalline form or an amorphous form. So solids can be crystalline or amorphous. If they're crystalline, that means they have a repeating structure. And if they're amorphous, it means the particles are disordered. So an example of a crystalline structure would be something like sugar or salt. And an amorphous solid might be something like glass or plastic. In either case, whether it's crystalline or amorphous, the molecules can't move freely. When we shift to a liquid, our particles are still relatively close together, but generally speaking, a little bit more spread out than in a solid. They have enough kinetic energy that they can slide, they can roll around. We talk about translational motion instead of vibrational motion. Liquids do not have a fixed shape. They're going to take the shape of their container, but they do have a fixed volume. They cannot be compressed. So solids and liquids of the same substance are often approximately the same size. The liquids are usually going to be occupy a little bit more volume because they are a little bit less dense. The particles are close together in both states. The temperature range where something is a liquid is entirely determined by the strength of its intermolecular forces. The stronger those intermolecular forces are, the higher the melting point and the higher the boiling point. All right, so gases, lots and lots of kinetic energy. It's enough that it's overcome the intermolecular forces that are holding those particles together. The particles are far apart, they're moving really quickly. Because there's so much space in between the particles, they can be compressed. They take the shape of their container, they can expand, they can be compressed, so they don't have a fixed volume. And then they don't have a regular arrangement of the particles. As you could say about liquids, they don't have a regular arrangement of the particles. So, and then we'll move into what we call the ideal gas law and the kinetic molecular theory, and we'll start to understand that the frequency and the strength of the collisions between the particles in the container depends on pressure, temperature, and volume. All right, so here begin our practice questions for this topic. So we'll pause here and I will see you in class. As always, if you have any questions, please let me know. Thanks, look forward to seeing you.